find the area of the first quadrant enclosed by the left side of the y-axis above the graph of cosine. So cosine goes up to 1. Call this 2 pi. Cosine graph looks like this. Again, if you don't remember exactly what cosine graph looks like, it's really not the end of the world, but you probably need to make a table and get some of the graph down. If you don't have a visual on the graph, it's hard to know what's the top and the bottom. And since you always try to do top minus bottom, that can be a problem. Although I guess if you do it the wrong way, you might get a negative answer. And for these questions, your answer should always be positive. Area between curves has nothing to do with direction, so always positive. Okay, and then we also have sine x. Sine x goes to the origin. And it looks like that. So in quadrant 1, also trapped in with the y-axis is this little piece in here. So I really did all of that graph just for me to realize that cosine is the function that's on top and sine is the function on bottom. Doesn't have to be a super accurate graph. Didn't even need any of this other stuff, but
Didn't
you
we
can.
already know that though? Because it tells us.
Yeah, I think the wording's kind of funny, but yeah.
Okay.
And one of those other questions had the wording backwards too, so I don't really trust it too much. But okay, so we can do integrate top minus bottom. 99% of the time it's top minus bottom. Occasionally it's smarter to do right minus left and do dy. But you can always do top minus bottom. You just might have to do like two pieces of it or 3 pieces of it to avoid the right minus left. But our top was cosine x. Our bottom was sine x. I can see that the x value that it starts at is 0, and then the x value that it ends at is right here. So I guess you could set sine x equal to cosine x and try to solve that algebraically, but when is sine and cosine the same thing in quadrant 1? At pi over 4, good. At pi over 4, sine is square root of 2 over 2 and cosine square root of 2 over 2. So that's unit circle. So that's the only way to really know where the right bound is. I guess you could maybe do it with algebra, but I feel like you still might need to know that. So all of that to set up the integration, and now we can integrate this. So the thing that I can take the derivative of to get cosine is sine. The thing I can take the derivative of to get sine would be negative cosine. We need to evaluate from 0 to pi over 4. So plug in pi over 4 the first time. So this would be square root of 2 over 2 plus square root of 2 over 2. Already know those are equal. That's why I picked that value. Plug in 0, 0, and 1. So you have 2 of these, and then a minus 1. But 2 times 2 cancels, and you're left with square root of 2 minus 1.